Good day. This is Deanne Lee at the Society of Integrative and Comparative Biology 2015 conference. I'm at the IOP Publishing booth, and I'm here with, is it Dr. Spagna?
Spagna.
Spagna.
Lasagna.
I love it, Spagna. So we're here. I'm here learning about Bioinspiration and Biomimetics journal, and he just blew me away. So tell me more about what this journal is all about.
So this journal was founded in response to a problem that we were facing in the field of biomechanics about 10-15 years ago, which was that we would create science that involved both biological principles and actual robots, physical models. And the papers that we were creating were not being accepted by the existing journals. And the problem was engineering journals didn't want the biology, and biology journals didn't really want the engineering. So what we ended up with was this was our solution, which is a journal that includes both papers that include both experimental biology, which is meant to by which we test hypotheses to figure out the mechanisms by which animals move and eat and forage and do all the normal activities that animals do. But then most of these papers also include a major component whereby they actually build a robot or some sort of physical model that allows you to test these properties on a simplified version of the principles that we've deciphered from biology.
Okay, so the inspiration part and the mimetics part, that's about inspiration and...
Inspiration from biology and mimetics via engineering and robotics.
So mimicking animal systems.
Right. Taking the properties of animal systems and building them into a robot. Mimicking makes it sound like we're just copying, but what we're doing is figuring out what works best from animals and using engineering and principles of robotics to replicate those in some way.
Sounds amazing. So my inspiration in this is I have a friend whose daughter, still in high school, she loves physics, but she also thinks she wants to be an MD. So would this avenue be ideal for her?
She could go a long way doing this kind of research. She could also go into what we call biomedical engineering, where you are involved in the design and the construction of prosthetics and things that you can surgically graft onto or into people. There's a lot of different ways she can go. What I would say to any student who's interested in physics is know all the physics and math that you can possibly know, and you can learn the biology and apply the physics and math, and you will go very, very far in whatever direction you care to go in.
I like this because it really reminds me of the entire, what I call the entire STEM avenue, science, technology, engineering, and math. It sounds like to me that you all really employ all of those individuals in these projects.
When we do it in the most integrated possible way, that's how it works. Yeah, that is true.
Amazing. That's exciting. So what projects do you work on personally?
I work on the evolution of locomotion systems in insects and spiders. So basically I'm trying to figure out how insects and spiders use 6 or 8 legs, these sort of multi-legged systems, to travel over difficult terrain, things like leaf litter or sand or things that are not normal or flat or easy to get through.